Good morning, Year 6. It's the 23rd of February, and today we're going to be continuing our work on shapes. And today we're going to look at the symmetry within shapes. You will need to be able to accurately draw lines of symmetry and accurately use a grid to complete symmetrical shapes. So you should have already completed your arithmetic practice, so we can get straight on to the lesson itself. So to start off, we're going to think about what symmetry is, and then think about some objects that are symmetrical. So symmetry is all about, make that line a little bit clearer for you. So all about things being the same on both sides. So if we've got our line of symmetry here, whatever's on one side of that line is going to be exactly the same on the other. Some people like to call this a mirror line or a line of reflection, but what we're talking about is the fact that everything on this side is reflected over on this side of the shape. So I wonder if you can think of any objects maybe around your home or any patterns maybe you can see in your house that have a line of symmetry and can be symmetrical. And we were thinking about this work when we were thinking about the work of William Morris, the painter, how he uses symmetry in his work. Pause the video and note down some things and objects that you can find that are symmetrical. Okay, so we're going to have a look now at symmetry within shapes. The key thing here is we've got a variety of shapes. Some of them are regular and some of them are irregular shapes. And it's important that we think about the difference between the two. Now, during the junior school, you should have uncovered the key to the symmetry of the lines of symmetry within regular shapes. And that is that if it is a regular shape, like a square, an equilateral triangle, and a regular hexagon on the board here, you will find that they have the same lines of symmetry as the same sides and the same angles. So a square has the same length of sides, the same size angles, and the same numbers of lines of symmetry. So we've got 4 lines here, so we are looking for 4 lines of symmetry. The same with an equilateral triangle. All the sides are equal, all the angles are equal, and there are therefore 3 lines of symmetry. And as it is with a regular hexagon, this changes somewhat when we get irregular shapes like the isosceles triangle here. So let's have a look at the square and identifying those lines of symmetry within it. So we'll have a look here. One of the big tips is if you divide your shape in half by going vertically down, you can start to identify whether there's a line of symmetry there as your first port of call. We've got one there. We can see there's a rectangular shape on one side and a rectangular shape on the other. Likewise, we can go across with our horizontal line there. We've got a rectangular shape at the top and one at the bottom, exactly the same on both sides. I know I'm looking for 4 because this is a regular shape. So I can see that if I use this vertices here across to the other, I've got a right angled triangle and a right angled triangle. And finally, my 4th line of symmetry, crossing that central point, can be found crossing between these 2 vertices here. So I've got my 4 lines of symmetry on my regular shape, my square, 4 equal sides, 4 equal angles, and 4 lines of symmetry. We can look the same at the equilateral triangle. In fact, I can just prove this is an equilateral triangle. It might not show so well on your screen, but if I rotate it round, I can see that it is the same on every side. And it should be, if it's a true equilateral triangle, it should have the same length sides, the same size angles. And that being the case, because we know it's a regular shape, so we're going to be thinking about it having 3 lines of symmetry. So I'm going to go with my strategy of going down vertically to find my first line of symmetry. Sometimes it won't have a line there, but it's worth checking that one first. Then I'm going to be thinking, oh, is there a horizontal one? Well, no, I'll put one there just to prove that. But I can see that isn't where the second line of symmetry is. I know I'm looking for 3, but that's not going to be one because the top is not the same as the bottom. So my line of symmetry is not correctly placed. So if I go to this vertices here and divide my shape across, you can see I've got a right angled triangle there and another one over the other side. And the same goes for the other vertices on the other side, crossing that central point there. So I've got my 3 lines of symmetry. Following on for this, we're looking at our regular hexagon. Well, I'm going to go with my strategy first. So I'm going to go with my vertical line down. I'm going to go with my horizontal line across. So you can see my vertical line down. I actually formed an irregular pentagon, a 5-sided shape, but it's exactly the same on both sides, and the same with my horizontal line across. Then I'm going to use some of the vertices to help me divide the shape up through that central point. So I can see I've got my irregular pentagon, using this point here. So I'm going to go to this vertices here, going across and start to see. Then I've kind of used all my vertices. I've used my vertical, I've used my horizontal, but I know it's a regular shape and I know I'm looking for 6 lines, and so far I've only found 4. So 1, 2, 3 and 4. Put them in different colours so it's helpful. So you might need to turn your piece of paper, turn your shape to find it. But I've got another one cutting across there. So I've got my irregular pentagon and my irregular pentagon on the other side. Can't think what colour we haven't used. You're probably shouting at the screen, oh, I'll try an orange. This one going across here is my 6th line of symmetry, and I can just check that that's got the same on both sides. And a mirror might be useful to check that what I see in the mirror is what's on the other side, because then I know I've got exactly where my line of symmetry is. The isosceles triangle, well, I'll start with my strategy of going down vertically, and I can find that I've got a lovely line of symmetry there. It's the same on both sides. But like this triangle up here, when I start to go horizontal, I can see that's not going to work. That one won't work there. Even if I start to use my vertices, you should be able to straight away see that this side of the line is not the same as the other side, even if I took the other point there. And I can just investigate as much as I like on that. Wherever I place my line of symmetry, I'm not going to be able to find another line of symmetry on there. So I've got 1 on my irregular isosceles triangle. The sides are not all the same and the angles are not all the same. So now it is over to you to do task 1. And as you can see, it's very similar to what we've just been doing. And you will need to find the lines of symmetry within shapes and then explain and reason about other people's investigation and whether they are correct or not. So pause the video, have a go at task 1, and I'll see you back here for task 2. So we're moving on to task 2 now, and sometimes we're looking at symmetry within a few shapes when they're being put together. This is a question that has come up quite recently, and it is all about using shapes to make patterns. So as you can see from these shapes, we've got 2 shapes here. I'm going to hide some information so it's not too overwhelming for you. We start off with this, that Amy has some circular tiles and some rectangular tiles. So we've already established what she's going to be using in her pattern for her tiling. And the first part of the question asks us to think about the fact that she's going to make some patterns with them. So we are looking at the pattern she's going to be creating, and we're going to look and see whether they have a line of symmetry or they do not. So we should be thinking about, do they have a line of symmetry? And there's lots of things that we should be thinking about as we investigate these patterns. So if we have a look at the ones here, the first thing we need to be thinking and establishing is that the line of symmetry might not be an obvious one. So we need to have a look at different angles. We might need to do some orientation of the paper, turning it round to see if that can help explore and show us where there might be lines of symmetry. As I'm doing that, some of you might be able to see, oh, actually I can see where a line of symmetry might go in some of those patterns. So you can see here, I'll start with my strategy. Well, can I go down vertically? Well, not on this shape. Can I try the horizontal method? of dividing my pattern, yes, there I can see I've got a line of symmetry. So the top here is exactly the same as the underneath part, and there's my line of symmetry. If I look at this one, try and use that strategy again, so I can try and place my line of symmetry down vertically, but you can see straight away that this is not the same as on the other side. In fact, if it was to be the same, I'd have to have my circle down there. It's not working in this pattern design. Likewise, if I try and use the strategy of dividing it across horizontally, you can see that already I should have had my other circle here for it to form a symmetrical pattern, and therefore this is not a line of symmetry there. So I've got one here already, or just taken that away. So one here I can do. Try and get that accurate as possible. Oh, already done a mistake there actually. So I was doing that across there. There we go. So I can find one in this shape, but this one I have not been able to identify a line of symmetry. If we look down to these two here, this is where the next one becomes a little bit tricky. So I can try my strategy of going down vertically and horizontally, and I think you can probably see by the way I'm using my cursor there, that's not going to work. It might help me here to start thinking about turning my paper. Okay, and as I do, I think probably some of you can start to see where if I go down my shape vertically and cut that central circular tile in half, I can get a line of symmetry in there, and I know that I've got a symmetrical pattern if there's a line of symmetry that I can make there. So there we go, I've turned it around. That helped me establish for me a line of symmetry. I'm going to have to turn that back around. Hopefully it won't going to stay, but it might. I'll have to redo that one to show you. So that one's going to be a diagonal line across there. That's where my line of symmetry is. This one, however, isn't going to be another problemsome one. If I try and go down vertically, it's not going to be the same on both sides, and hopefully you can see that. And horizontally, similarly, I would have to have that circle here and that square over there. Sorry, that rectangle over there. So that's not going to work either. If I try and go diagonally across, well, you can see this is all right, because they're both the same on both sides, but this shape here should be going away from me here. So I would be seeing, oh, I'm trying to draw it with a line, I would be seeing it going a little bit like that if I was doing a diagonal pattern. So that one is also not going to work. So a lot of this is about using your vertical and horizontal lines as a starting point, but also looking at turning the paper so you can investigate whether there is any diagonal lines of symmetry that can be found in the shapes and the patterns that are being created. So with that in mind, I'd like you to pause the video, and if you can then have a go at task 2. When you're ready, I will go through task 3. Hello and welcome back. We're ready now, hopefully, for you to have some input for you to be able to go on to task 3. So sometimes you are not asked to find a line of symmetry within a pattern or in a shape, but you're asked to complete the rest of the shape given where the line of symmetry is. And like I said earlier, this is sometimes referred to as the mirror line or the line of reflection. So with this, there are a couple of strategies, but you do need to definitely use a ruler. But you'll also need to reflect on the things that you were looking at in the translation work yesterday. And that's about labeling vertices to help and support you to create your symmetrical pattern or shape on the other side of the line of symmetry, or the mirror line in this question. So sometimes it might also be useful to turn your paper and shape and help you see it from a different angle. I know that helps quite a few of us to access problems where we find it hard to see spatially where the shape is, what the shape should look like and how it should look formed. So you might want to change the orientation of your paper and turn it round to help you. So for this, you can see we have got lots of different vertices for our shape here. So if you can see, I'll just indicate them to you. There are 2 which are on the line of symmetry already. So those will be our starting points. They've not gone away from the line at all. They're just our line of symmetry there, so we can see. There are some that are further away from the line of symmetry, and they're the ones we're going to need to think about plotting on to the other side of the grid, so that we can then start thinking about what the second half of our shape will look like. So these we know as our starting point. We don't need to replot them. They're going to be exactly the same place. If we wanted to enable them, we could, but there's not really much point because it's already been put in place for you. So I'm going to go back to our translation work, and I'm going to label this A and B. And using our grid, we can start establishing how far is this point A from our line of symmetry, our mirror line, our line of reflection. So if we have a look here, we have got, here's our mirror line, we've got 1, 2, and 3 squares away. So we have to do the same on the other side. So we've got 1, 2, 3, and it's got to be in line with that point you are reflecting. So there we go, there's our point A. Same happens here with B, so we're going 1, 2, 3, and the same way we go 1, 2, 3 here to establish that vertice there. So once we've got those points, we can do as we've done before, we can start joining them up to form our shape. So here we've got these 2 joining up from A and A, and then the final one going across there. So there we can see we've created our own reflection of the shape, and we might have wanted to turn the paper so that could be clearly seen. So that will hopefully help you to get ready and started for task 3. There are some more complex shapes here, but the same principle applies. You've already got your points by the mirror line, so you can start with those, and you can see where there are some points from the line that you can count away from it. So we've got 1 there, you've actually got a little 1 here that you can mark, and over on this point here. So we could label that A. That was A, and it was 1, 2, 3 away from the line. I'm counting 1, 2, 3 a line to plot over this side, and then joining up those points to create my line of, my symmetrical shape, and where my line of symmetry runs down the middle, my mirror line. And you've got several that are like that. Some of them you've been asked to complete the shape, put your actual line of symmetry in. Some of them the line of symmetry is already there. Some of them are more complex patterns. I think we had a go at one of these before in class, so hopefully that will help. And there's a little end task of putting the letters and think about where their lines of symmetry are on this Carroll diagram here. And as always, the answers are at the bottom for you to check through and check you're on the right track. Some of you might therefore use that as a way of speeding through, or I can do this, I need to move on to challenge myself a bit further. So that's the end of today's lesson about symmetry. Good luck completing the sheets, and obviously send those into your class teacher so they can see how you're getting on also. Goodbye, and I will see you tomorrow for some more shape work.